Hello everyone, welcome or welcome back again to another video from the EP3X Institute of Mathematics Education. My name is Akin, your math instructor, and in today's video, which is a continuation from our most recent upload of transformation geometry involving reflection. In our previous tutorial, we had an elaborate discussion and of course an elaborate explanation on the concept of reflection. In our previous video, we had already looked at non-standard reflections. We looked at reflection metric, how to derive the reflection metric, and of course how to use the graphical application to reflect an object across a standard and non-standard mirror line. So of course, if you have not checked that video out, please be sure to do so. A link will be pinned in the comments that will take you directly to that video, because of course in today's lesson we're going to be picking up from where we left off in that video. We're going to be applying all those concepts to the demonstrations that are here. So of course, if you have not watched that video, it is highly recommended that you do before continuing on this one. And of course, if this is the first time here on the channel, do not forget to hit the subscribe button below and turn on your post notification bell for daily and weekly uploads in preparation for your exams coming up. Of course, my channel primarily caters for Caribbean students, that is students that are doing math exams, math preparations under the CSEC, that is the Caribbean Examination Council math curriculum. But the contents here are spread wide and far. So whether you're doing college math or you're doing CSEC math or secondary education math, the knowledge here related to the topic, if you find this video, then most likely you're having a challenge in this topic, and hopefully at the end of this video all the objectives will be met. So of course, again, do not forget to hit the like button. It really does help the channel to grow, guys. For every one of you guys, please help me out by helping the channel to grow. Share this out to your math communities. All right, so without further ado, let's jump right into the lesson. Here we go. So of course, we already went through the preliminaries of talking about standard reflections: reflection across the x-axis, reflection across the y-axis, reflection across the line y equal x, reflection across the line y equal negative x. We looked at the transformation metric, how to derive the metric, and the changes that occur after the point of reflection. Now we're going to be going ahead here to do the calculation aspect, using the metric then to multiply with the object point or points to attain the image. Now there's many ways to go around this, but for the purpose of examination, you guys are definitely wanting to know how to connect the topic of matrices with the topic of reflection. So here it says that the correct way to calculate the image of an object under a reflection is to use the metric multiplication. Reflection metric multiplied by object equal image. Now to demonstrate this, I have a question here on screen that I'm going to be then transferring to the graph, and then I'm going to be using the reflection metric to do the calculation. So here it says that given that the triangle T, that's the name of our triangle, is drawn by joining the points x, 1, 2, y, 2, 5, and z, 4, 1, undergoes 3 reflection transformation, which is, of course, one is going to be in the x-axis, one is going to be in the y-axis, one is going to be in the line y equal x, and one is going to be in the line y equal negative x. I made a mistake here by saying that it's going to undergoing 3. It should have been 4 transformations. Now, it is of course important for me to say to you here that on an actual exam, you're not going to be asked to reflect the object through all 4 lines. They're going to pick a random line to which they would like you to reflect the object through. So it's going to be imperative that you know the different changes that occur in the different lines. Forgetting this information might prove futile, might have your attempts proving quite futile. So you definitely want to be very familiar, which I highly recommend that you check out the elaborate video that I just posted prior to this one. All right, so of course, say here, let's go ahead and start off by plotting our points on the graph. Okay, so let's just move our let's just keep our graph right there. Okay, and so first point here is 1 2, then 2 5, then 4 1. So 1 2 2 5 4 1. So 1 2 then is going to be, say here, 1 to my right. So that's from the origin here, 1 to my right, 2 up. That's going to be my position, and that's going to be my x. Even though the triangle is labeled T, it has a x vertex here. And then of course we have 2 5, so that's going to be 2 to my right. So that's going to be from the origin here, 1 2 and up 5, 1 2 3 4 5 right here. That's going to be my y vertex of my triangle. And then of course finally then we have the point 4 1, which is my z vertex. 4 1, that is 1 2 3 4 1 4 1, and that's going to be my z vertex. So therefore then I'm going to be drawing, let's just move this x from here, put it here. Then we're going to be connecting y to, say here, x. It's not a little bit straight here, guys, so let's just try that again. Okay, still a little bit not straight, so that's much better. And then of course we're going to go ahead here and draw from y here to z, and then of course we're going to connect from x here to z. All right, let's just put some circles around this here, and just to ensure that we label our points clearly, we know exactly where it's standing. Okay, and that's going to be our object. Now let's go ahead then and proceed, because they did say to us that the triangle is T, so we can just label the whole entire triangle T. All right, beautiful. So then they're asking us to say here, reflect it across these 4 standard mirror lines. Remember, in part 1 we went through the whole aspect of reflecting it across non-standard lines. Now we're going to be looking at reflecting it across standard lines, but we're going to be doing the calculation. So here then I'm going to be starting off with reflecting it across the x-axis. So of course we therefore then need the reflection metric for the x-axis. All right, so of course, presuming or assuming then that you already know this information, then of course then we are going to say that the reflection metric for the x-axis is that the x value will remain the same and the y is going to, say here, change. So therefore then it's going to be 1 0 0 minus 1. That is the reflection metric. Now, as I said here, the correct way here is to take the metric here, 1 0 0 minus 1. Then we're going to therefore then multiply it with the points 1 2, that's A, 2 5, that's B, pardon me, 1 2, that is point X, 2 5, that is point Y, and Z is 4 1. So let's just label here, this is X, this is Y, this is Z. And then of course by doing row by column, then we're going to actually get the metric, the coordinates of the image, say here, X prime, Y prime, and Z prime. Okay, so we're gonna go row by column here. Basically then we're just multiplying the top numbers by 1, and we're multiplying, say here, the bottom numbers by -1. That's basically what is happening. Okay, so row by column, that's exactly what's gonna happen. 1 multiplied by 1 is in fact 1. 1 multiplied by 2 is in fact going to be, say here, 2. 1 multiplied by 4 is 4. Let's go to the bottom and multiply here by -1. So we have -1 multiplied by, say here, 2, so that's basically negative 2 here, and then say negative 1 multiplied by 5 is negative 5 here, and then of course negative 1 times 1 is negative 1. So basically then we end up with the coordinates of, say here, x prime, y prime, and say here finally z prime. So if we go on our graph then and we plot say here the points that we've just calculated here, then you're going to find that across the x-axis the image should land somewhere down here, because it's going to jump across the x-axis. And so here 1, negative 2 means that I'm going to take 1 step to my right and 2 steps down. So that's going to be, say here, that's going to be my x prime. And so therefore then I'm going to go ahead then and I'm going to plot, let's put the x prime, let's put the label right above the point, and then say here then y prime is 2, negative 5, so I'm going to go 2 to my right and 5 down, 1 2 3 4. Say here, let's just, okay, so let's go 1 2 1 2 3 4 5. So that's going to be, say here, all right, and we're going to go ahead then easily and let's 1 2 1 2 3 4 5. Do apologize for that, guys. Okay, that's going to be my y prime, and then of course I'm going to plot 4, negative 1, so that's 1 2 3 4 negative 1 right here, and that's going to be my z prime. Okay, and so therefore then let's just use a different color ink here. Let's use pink, and to connect x prime to z prime, connect x prime to y prime, and connect z prime to, say here, y prime. And then therefore then we have a beautiful image here of a reflection across the x-axis. And just to connect our previous video with what we are currently learning now, you're going to find here that easily then x is 2 units above the x-axis, so automatically x prime is going to be 2 units below the x-axis. Z is a mere 1 unit above the x-axis, so z prime is going to be 1 unit below the x-axis. And of course y here is 1 2 3 4 5 units above the x-axis, so y prime is going to be 1 2 3 4 5 units below the y-axis. So you can see that the calculation actually aligns with the graphical demonstration. Now we could have used the say here graphical demonstration to get our answer, because unless the instruction in the question specifically states that you should show your calculation, then by all means you can reflect your object using whatever method you see fit. All right, so nicely done there, nicely done. Let's then move on to, just gotta create some space here. Make sure that you guys have the solutions here on your worksheet as you're watching this video. So we're gonna need some space here, so let's just erase this section here, and then of course just replace here let's just replace everything here, and let's just use a different color ink then to demonstrate this example. Now we're looking at again the reflection metric for, in this case here, the y axis. So that's the y axis. And so for this then we're looking at the fact that say here xy will then eventually change the x value, the x ordinate, and the y is going to therefore then remains the same. So therefore then the metric for this then works out to be -1 0 0 1. So once again we're going to be using, say here, that metric that is -1 0 0 1, and we're going to multiply it again by the object that you're reflecting. Now bear in mind that when you read the question, sometimes they'll ask you to reflect the original object, or sometimes they'll ask you to reflect the image. So you have to read the question to know whether it is that you're reflecting the original or you're reflecting a different shape that is on the diagram here. All right, so again I'm just going to be sticking with reflecting the black object here, the triangle that is drawn in black. So once again the same point becomes here 1 2, then we're going to have, say here, 2 5, and then we're going to also have, say here, 4 1. Okay, so we're gonna have 4 1. Let's just get a little bit of zoom here on here for screen for you. So then let's go ahead and do our row by column here. So let's just write this number a little bit better. That's 4 1, and this is in fact a 5. So then row by column, that is row here by column. So this -1 here will multiply the top numbers. So okay, so this is going to be equal to -1 times 1 is -1. Okay, that's going to be my x, let's call it double prime here. And then now we're gonna have, say here, -1 times 2, that's going to be -2, and then that's going to be my x coordinate of my y double prime here, and then of course -1 times 4, that's -4, that's going to be the x coordinate value of my z double prime. So at the bottom then we're gonna go then and we're gonna say here 1 multiplied by, say here, 2 is 2, and say here 1 multiplied by 5 here is, say here, 5, and 1 multiplied by 1 here is, say here, 1. Okay, and of course these becomes the coordinates of my object point here. So therefore then let's go ahead and draw our blue triangle. So that's going to be -1 to the left and 2 up. So from the origin here, -1 and up 2, that is 1 2. So that's going to be, say here, there, that's going to be my x double prime. And so -2 5, that's going to be from the origin here, 1 2 1 2 3 4 5. It would be really good, guys, if you guys have a graph paper that you're working with me and you're already ahead of me, so you're going to be matching your solutions with mine. It would be really good if you can do that. But if you're not and you're just watching, then that also works. But it really does help when you guys have a HUD that is all hands on deck. Finally then, -4 1, so that's from the origin here, 1 2 3 4 negative, and up 1 here, and that's going to be my z double prime. Okay, we use a double stroke just to differentiate between the objects. Now here, let's just connect here with bright. Most times when I'm drawing my image, I tend to draw it with a broken line here if I'm using the same color ink, right? I tend to use a broken line, but because I'm using my digital tools here, I'm able to use different colors to differentiate between my object and my image. And so therefore then beautifully we have our reflection of triangle T here across the y-axis being this blue triangle here. So let's call this, say here, T double prime, and let's just call this one down here, say here, T single prime, just for the purpose of identification. All right, beautiful. And we can double check on this, guys. All right, remember that this video is an elaborate video. We have to make sure that everything remains consistent with what we are told. So again, here you'll see that y is a mere 2 units away from the y-axis here, so it's going to be 2 units on the other side automatically. So there you can see that the calculation matches up with the graphical representation here. Tx here is just a mere 1 unit away from the y-axis, so it's going to be 1 unit on the other side as well. And z here is going to be 1 2 pardon me, z here is going to be 1 2 3 4 unit away from this red y-axis here, so it's going to be 1 2 3 4 units on the other side of the y-axis here. So it matches perfectly with what we are looking for. All right, and that's basically what any transformation question at whatever level or whatever exam body you're studying math under, this is what it requires, a row by column transformation. All right, so once again we need some space for this one here, so we're just going to erase all of this information then, and then we're going to be moving on to our next transformation. Okay, so then let's go ahead then. I'm looking for, say here, the reflection matrix for, say here, the line y equal x, and so of course then if we have a random point, say here xy, and it goes through, say here, the line y equal x, it's going to literally flip. It's going to have an interchange in the position. All right, and so therefore then easily you're going to find here that the matrix here is going to be, say here, 0x, that's 0 here, and say here 1 y, and at the bottom here we're going to have 1x and say here 0y. Okay, 0y. All right, and so we're going to take that matrix then 0 1 1 0, and we're going to multiply it again by all those individual points then. So therefore then we're going to multiply it by say here 1 2. We're going to multiply it then by also 2 5, and then we're going to multiply this here by say here 4 1. Remember that this is our original x, our original y, and our original z. Now in my previous calculation I had shown you guys that all we're basically doing is then multiplying by the numbers by 1. Now if we go ahead and we just say 1 times 1, 1 times 2, 1 times 4, we're literally not going to get a change in the points. Now row by column, meaning that the 0 here multiplies all the top. Okay, so row by column then 0 times 1 is 0, and then we have 1 times 2 is 2. So with this flip here, these two top numbers here, this 1 here is actually multiplying the bottom numbers, okay, and then this bottom 1 down here is multiplying the top numbers. I find it a lot easier if just knowing that the points are going to flip. This is just simply going to become, say here 2 1, 1 2 gets flipped, becomes 2 1, 2 5 becomes 5 2, and 4 1 becomes 1 4. And this is kind of easier because you may be watching this video without the prerequisite skills of say here matrices, and if you don't, you simply have to just understand that under a reflection in the line y equal x, the original coordinates are going to interchange. So once we go through this rotation matrix, row by column here is going to have a flip 2 1 5 2 1 4. Now if you want, you could go ahead and do the whole row by column 0 plus 1 or 0 plus 5 or 0 plus 2, and then you're gonna have 1 plus 0, 2 plus 0, 4 plus 0. If you want to do that, you can, but it really is not necessary because of course we already know that the points are going to say here flip. So if we do just that, then we're gonna go ahead and plot say here x, let's call that triple prime 3 strokes here, then we call that y triple prime, let's call this z here triple prime. Okay, and so 2 1 then is going to give us say here 2 to my right and 1 up here. All right, and then we're going to end up with say here 5 2, so that's 1 2 3 4 5 up 2, that's right here. Okay, remember that on an actual exam you're not going to have so many different shapes on the same graph. You're just going to have 1 or 2 shapes. 1 4, so that's 1 to my right, and 1 2 3 4 up. So basically then we end up, let's just label this, let's just zoom up here and label this. This is going to be my x. Okay, let's just a here. Okay, so we have x triple prime, we have I think 5 to, okay, so this is y triple prime, and then this is going to be, this is actually, let's see here, y triple prime, that's 5 2, yes, and then z, that's 1 4, so this is z here triple prime, so z here 1 2 3, just to differentiate here. All right, now I'm going to be using broken lines because I'm having an overlap. So here, just going to connect this to this here, then we're going to connect this to this here, and then we're going to of course connect this to this here. Now one of the challenge that you might encounter, and it depends on the level of math that you're doing, or it really depends on how in-depth the question is, then let's just say for argument purposes or for conversational purposes, you may get this black triangle here along with this purple triangle here. It's kind of really difficult to even know that that is actually a reflection across the line y equal x. Number one, you're not actually seeing the line y equal x. We know it's going to be, say, here and here. We know that for sure, but we're not actually seeing the line. So it's going to be a little bit hard to predict, which, as I said, it comes with a little bit of experience, the process of elimination, because when you look at the black triangle compared to, say here, the purple one, it is definitely not a reflection in the x-axis, and it most certainly is not a reflection in the y-axis. So by process of elimination, it can either be a reflection in the line y equal x or y equal negative x, and it most likely is not. It's possible that it could be a non-standard reflection line where the line is actually running through the object. It's possible, but like I said, this comes with experience when it comes to identifying the different types of metric. All right, but for this one here, it's a reflection in the line y equal x. All right, so finally then, let's go up top here and erase this information here. All right, and then now we're going to move on to the final line of reflection here. So we're going to be looking at, say here, this orange. Okay, so we're going to end up now, say here, with the reflection metric for, say here, the line y equal negative x. And so any random point, let's just extend this arrow here. So any random point, let's just say xy random point, goes through a reflection in that line, will automatically have the ordinate values interchanging, and there's going to be a change in the sign, not necessarily, as we said, to negative, but a change in the sign. If they're all positive, they will then flip and become all negative, and if they're all negative, they will flip and then become all positive. And of course, if they're negative and positive, they will interchange signs. So therefore then, to move from here, then we're looking at, say here, negative, pardon me, whoops, there's no x at the top, so that's 0, but there's a negative y at the top, so that's negative 1, and at the bottom there's a negative x here, and then at the bottom there's no y here. So that's our reflection metric. Then we're going to be using 0, -1, say here, -1, and 0 to, say here, multiply the points 1, 2, I think it was, let me look at the object, the original object. So I think it was 1, 2. Yes, it was in fact 1, 2. Let's just have a look at it up here, 1, 2, and then we have 2, 5. So that's going to be 2 here, 5, and we have 4, 1. We have, say here, 4, 1. Okay, and so of course, after going through the whole row and column, you're going to find that the points are going to in fact flip. So 2 is going to go up and it's going to change to negative, and 1 is going to go down and it's going to also change to negative. And see here, 5 is going to go up and change to negative, and 2 is going to go down and also change to negative. And then 1 is going to go up and of course change to negative, and 4 is going to go down and change to negative. And that's going to become, let's just call this, say here, x, kind of hard to put 4 strokes here, so let's just call it x sub 4, y sub 4, and let's just write it a little bit better here. Okay, just keep everything neat and tidy. So let's just call this x subscript 4, y subscript 4, and z subscript 4. Okay, and so therefore then we're going to plot our points on the graph. So -2, -1, so that's going to be -2 to my left, that's 1, 2, and 1 down here. That's going to be my x sub 4. Let's just label that right away, x sub 4. All right, that's my fourth transformation. All right, then we're going to go ahead and plot -5, 2. So that's going to be -5 to my left. That's 1, 2, 3, 4, 5, and down 2, 1, 2. That's going to be, say here, my y subscript 4, and then of course z, which is -1, 4. I'm going to have, say here, -1, down 4, 1, 2, 3, 4, right down here. Okay, and that's going to be my z subscript 4. So then I go ahead then and connect this line here with, say here, this line here, and then we're going to connect this line, say here, and that basically forms the reflection of the black triangle here to the orange one here. Let's just pretty much call this, say here, T subscript 4. Okay, it's kind of overlapping with the black one here, so I'm not able to leave with the purple one, but we can leave with the purple one. Let's just call it, say here, the purple one here, let's label it T subscript 3. All right, and that basically shows how you use the reflection matrix then to multiply by the object points to attain the image points. Again, you could actually do this without, if you notice here that on this particular diagram that you're drawing here, we did not need to draw the line y equal x and y equal negative x. If you had watched the previous tutorial in the introduction of, say here, reflection, then of course, say here, you would have seen where I was able to actually go ahead and count diagonal units across the line. But in this example here, we didn't actually have the line. We weren't able to see the line, so we weren't able to use that technique. We literally had to know what the coordinate values are and the changes. All right, so that takes us to the end of this first segment of the video. Be sure to hit the like button if you have gotten a little bit more clarity on this particular topic here, or this particular part of reflection. Now let's move on then next to talking about the properties. Here is the challenging part. For exams, most times you will find that they tend to ask you to describe the type of transformation that is presented. And so the challenge here is not necessarily going to be occurring now, because obviously this video is geared towards reflection, so everything that I'm going to show you now is going to be obviously reflection. What usually happens is that after learning all the different types of transformations, starting with translation, reflection, rotation, enlargement, combined transformations, you know, when we look at all of those, then we get a random diagram on a random day doing a random exam. You know, is how do I know if the particular diagram that is drawn is in fact a reflection as opposed to being a translation, a rotation, or an enlargement? And then this again boils down back to having some basic foundation identification knowledge. So when we look at the properties of a reflection, what we're looking at then is reflection is most times the easiest and easy to identify. However, when it's a diagonal reflection, for example, in the line y equal x or y equal negative x, we mentioned it earlier that it can be a bit challenging for many students. Now, you're going to use the following guides. These are the guides that I use all the years that I've been teaching, and it has worked for me. It has worked for a few of my past students, and so of course, hopefully it will work for you here on the channel. Okay, so number one of the things that I use to recognize if a reflection has taken place is if the object and the image are identically opposite. Okay, identically opposite, meaning that they are the same shape, but of course they're turned backwards or the upside is down. So they're identically opposite in appearance. They're an exact mirror of the other. So if you go back to our previous diagram that we have here, you'll recognize easily then that if you were to compare the black triangle here with the pink triangle here, you notice that Y was at the top, but then of course when you look at the image, then Y ends up at the bottom. And there you can see that X is on the left side of the black triangle, but under the reflection, X is now, well, X is still on the left side, but it's just that X was at the bottom half, down at the bottom of the black triangle. Notice now that after the flip, it ends up at the top. Similarly, Z was at the bottom here of the black triangle. After the flip, it ends up at the top. So that's usually like an identification catalyst that I use to recognize whenever a reflection takes place. It's the very same thing with the blue triangle here. Y is actually say here on the, it's more on the left side of the triangle here, but then you can see that it's more on the right side of the triangle here. See here that X is on the left side here. Now X is on the right side and Z is on the right side here. Z is now on the left side. So there's a slight change in the orientation of the shape. Now, as I mentioned earlier with the purple and the black, it's a little difficult to like write out, look at it and say, oh, this is a reflection in the y-axis for many students, unless you have experience in knowing exactly that these type of overlaps is a reflection. Then you may have to use what is known as the process of elimination, but we're going to dive into that later on into the video. Now, another thing that I actually use to help me to deduce that, say here, the reflection has occurred is the fact that the object and the image are equidistant apart, whether it be vertically or horizontally, or it also could be diagonally, depending on if it is that the shape is perhaps say a right angle triangle. Okay, and they must be in the exact same vertical, horizontal and diagonal path. Okay, so then the third one that I use now is the position of the signs. This one I use the least. It's kind of challenging to like look necessarily at the points and be like, okay, then 2 3 becomes, say here, minus 2 3. I mean, I can, but I mean, property number 1 and 2 kind of just never fails, so I never have to use property number 3. But for some students, funny enough, that they might find this quite easy, just looking at the points and be like, okay, if the top number changes, then they know that it's a y-axis reflection, or if it's a bottom number, then if the bottom number changes, then it's a x-axis reflection. So some students, every student is different and they view the math differently. So then what we're looking at then is the fact that we could look at the signs of the ordinate values and if they change. All right, so here I have a graphical demonstration here that I obviously got from a Google website here that shows here that, let's say that you go on an exam and this is what you see presented on paper. All right, how are you going to know if this is a reflection? Well, I mean, at first glance, you could almost guess it's a reflection. But then you have to also remember that there's 2 categories of reflection. You have non-standard reflections, and you have, say here, non-standard reflections, and you have standard reflections. So when you're checking, when you're going to describe the reflection, remember that a reflection requires you to describe the line that it's being reflected through. All right, so here for this example, you kind of see here where I've already highlighted, say here, that the reflection line is this red line here. But let us just say, for example, that you recognize that it was in fact a reflection, and you recognize that it jumps from the top to the bottom, but then you made a mistake by saying, say here, it's a reflection in the x-axis. Let's check why it is not a reflection in the x-axis, because here you can see that A is a mere 1 unit away from the x-axis, but then A prime is actually 3 units below the x-axis. So therefore, there's no equidistance between the object and the image. And just that information alone will suggest to you that the axis or the mirror line here is not in fact the x-axis. So what you can do here is definitely count the distance between A and A prime. So you can see that this is, say here, 1, 2, 3, 4 units. And so therefore, if it's 4 units between the object point and the image point, then of course 4 divided by 2, because a mirror line cuts it halfway, it's 2. So the mirror line is going to be located 2 units below the object, or 2 units above the image. So in this case here, 2 units below the object is 1, 2, which lands us right onto this red line here. And then of course it's going to be the same here, 2 units above the image, landing us right on this red line here. Then we would basically draw the red line through that point here, because it goes from top to bottom, so it has to be a horizontal line. And so therefore then we need the equation of this line. All right, we need the equation. It's not just to say that it's a reflection across the red line. This is just a very pre-constructed diagram for you here. it's actually, notice that the red line is passing through the y-axis, and it is passing through -1 on the y-axis. So therefore we can safely say that this is how you would describe it. You'd say triangle. Let's go ahead and write here, say triangle, or you can write out the word triangle. A, B, C describes a reflection across the line and it passes through -1 on the y-axis. So it passes through the line y equal -1. So confirmation that this is in fact a non-standard reflection. All right, beautiful. So that is how we actually go around that particular problem there. So it says describe fully the transformation that maps triangle ABC onto A prime, B prime, C prime. Clearly the description is that it's a reflection and it jumps or it flips across the line y equal -1. Beautiful. Next then, we're going to be looking at a more advanced concept. Now, you're going to find that occasionally, for the CSEC students that are watching this video, this question will pop up now and again. It's not very routine question. It's not a routine question, but it is in fact a question that you definitely need to have a basic understanding of, and it's what is called inverse reflection. And so inverse reflection is basically where we are trying to determine either the metric that reflected the object onto the image, or we are trying to reflect, or we are trying to attain where the object was. So inverse means opposite. Now here on screen it says that one, occasionally you'll find where the reflection transformation is stated and the image point is given, but you're required to determine the coordinates of the object. Or it's possible that you can be given the object and image points. So you can be given the object points and you can be given the image points, and you're required to find the transformation metric. So I have an example here for you that demonstrates this calculation here. And it says that in example 1, given that the point P, so I'm just using a single point to demonstrate the calculation. Given that the point P has coordinates AB, which in this case, obviously, this is our object. So therefore, the object here is represented by two unknown variables A and B. And it undergoes a reflection under the line y equal -x, which we already know from previous explanation that the metric for that already is going to be, say here, 0, -1, -1, 0. All right, already we know that. Again, if you don't know the metric, then it might be a challenge. So you have to get into the habit of knowing the different metric that matches the different standard reflections. And of course, we are being told that it has been mapped onto the point P prime. We already discussed this in part 1, that when you see a prime or it says mapped onto, then that becomes our image. So in this case here, we are given the image location, we are given the transformation metric, but we are being asked to calculate the position of the object. Now, say here, part 1, state the 2x2 metric that represents the reflection transformation of y equal -x. We just did. It is in fact, by knowledge, 0, -1, -1, 0. All right, that's how CSEC normally states the question. They normally state the question, say here, in parts. So right away here, we know that the reflection metric, let's just write it in the space here, is equal to 0, -1, -1, 0. And then it says using a metric method to calculate the coordinates of AB. So we have to use a metric method. They're specifically telling us to use a metric method. Then this requires us to go back to what is known as the rotation metric formula. We had discussed it earlier in the video. Here it says rotation metric multiplied by the object point gives us the image. So therefore then, let's go ahead and write down that formula then. So we're looking at the fact that R rotation metric multiplied by, say here, the object is equal to the image. So we know that the rotation metric here is in fact 0, -1, -1, 0. And then of course, you'll see here that the object point is unknown. So we're going to go ahead and say A, B. And then of course, we're going to equate this to, say here, the image point, which was told to us to be 3, -2. So that's 3, -2. So therefore then what this means then is that we're going to be forming a pair of linear equation and we're going to be solving them. And of course you can check out my complete tutorial guide on solving linear equations. So we're going to go row by column. This is where you the whole row by column matrices is somewhat sort of unavoidable. So here 0 times A gives us 0 plus -1 times B gives us -B. So 0 times A, so that's first times first and second times second. So 0 times A is 0, and then we're going to have -1 times B is -B, and then that's going to be equal to, say here, 3. And then of course at the bottom now we're going to go row by column. So that's -1 times A, that is going to be minus A plus, say here, 0 times B is 0. And that therefore is going to be equal to, say here, -2. Okay, so therefore then to solve this equation, we're going to therefore just simply transpose. Since our subject is negative, we're going to bring this over here, and then we're going to bring this 3 over there. We know we don't like our subject being negative. So therefore then for this one then we end up with 0 take away 3 is equal to positive B. So therefore -3, 0 take away 3 is -3, and that's equal to, say here, B. And then at the bottom then we end up with -A. We're going to go ahead then and just pretty much transpose the -A to that side, and then of course carry the -2 to this side here. So -2 comes over, becomes +2, and -A goes over, so this is plus 0 here. -2 comes over, joins the 0, so that's 2 plus 0, and that's equal to -A becomes +A. So therefore 2 is equal to A. So therefore our two solutions that we're looking for is that B is equal to -3 and A is equal to, say here, 2. So you've got to look out for little questions like these. This goes beyond just the basic scope of just understanding that a reflection is in fact a equidistance method. That's when it's graphical. When it's not graphical, then you know a little bit of algebra is going to come into play, a little bit of matrices is going to come into play. So you definitely want to give that one a try when you see it. Let's look at example 2 then, where we're actually looking for the transformation matrix perhaps. So it says here in example 2, transformation T and Q are represented by the matrix. This should not have been transformation. Let's see. Transformation T and Q are represented by the matrices. T is A0, B -1. Looks very complicated, doesn't it, guys? It does, but it's not. It really isn't. Let's just have a look at how to evaluate this. So matrix T is A0, B -1, and matrix Q here is P0, 0, Q. So basically T is a type of transformation. We don't know which one is it. We don't know if it's a, say here, just a made up transformation, or it's going to be a standard transformation like a rotation or an enlargement, or it's going to be a reflection. We don't know. And Q, same here, we don't know exactly what matrices it's going to be. But what we do know is that transformation T, this matrix here, basically maps, say here, the point R, which is the object in this case, so it maps R, the object, onto, say here, R prime. This actually should have been R prime, guys, my apologies. That's R prime to 1. So this is our image. So basically then we're going to be trying to find out what is the values of A and B that would cause 2 minus 1 to map onto R prime to 1. We could use advanced knowledge and skip through the whole calculation, but I don't want to do that. I want to show you how to calculate. And similarly then, transformation Q maps, say here, point S, which is minus 5, 3, onto, say here, S prime, 5, negative 3. At this stage, just looking at the points is not going to suffice, because at this stage here, you would have already been exposed to rotation, you would have been exposed to enlargement, you would have been exposed to translation. It's going to be all a little bit blurry. So sometimes you have to just go back to your fundamentals. So we're going to go up here, we're going to create some space up here and do our calculation. All right. Do I need space at the top? Oh, yeah, I'm going to use a space at the top here, guys. All right. So here we go. So let's start off with transformation T, which we know is going to be the rotation. It's going to be the matrix, the transformation matrix. Let's write the formula first. In this case, we're going to use the formula transformation matrix because we don't know what transformation it is, multiplied by, say here, the object, and that's going to give us our image. And in this case, the transformation matrix is in fact A, 0, B, negative 1. And then we know for certain that it's going to multiply this point here, which is 2, negative 1. And we know for certain that after the multiplication, it's going to pretty much gives us the image point to 1. So that's what we know for sure. So once again, we're going to go through the whole process of doing this row by column. If you have prerequisite knowledge on, say here, matrices, this is going to be a little bit easier. So here what we have is A multiplied by 2. So that's first with first. A multiplied by 2. That's going to give us 2A. And then of course 0 multiplied by negative 1. 0. Okay, just a second here, guys. So it gives us 0. So that's plus 0. And then of course at the bottom now we have B first down here with first up here, so that's B multiplied by 2, that's 2B. And then of course we have negative 1 multiplied by negative 1 is going to give us positive 1. And then that's going to obviously be equal then to, say here, 2, 1. All right. And so therefore then, easily then, we're going to go ahead and equate the matrices. So we end up with equation 1 being equal to that 2A plus 0 is equal to 2. We can just go ahead and solve that equation immediately. We can transpose the 0. But we know that when we transpose 0, we're going to get minus 0, and 2 minus 0 is in fact 2. So we end up with 2A being equal to 2. And so we can easily then divide, say here, both sides by 2. So 2 divided by 2, that works out to be equal to 1. All right, that's the first equation. Second equation then is that 2B plus 1 is equal to, say here, 1. So we can go ahead and transpose that 1 over here. We end up with 2B being equal to 1, take away 1. So that's 2B is equal to, say here, 0. And of course, if we divide both sides, say here, by 2, we end up with, say here, easily 0 divided by 2. And that's, say here, 0. So if we divide both sides by 2, B works out here to be 0 divided by 2 is 0. So therefore then we have our two solutions, that A is in fact equal to, say here, 1, and we end up with, say here, B is equal to, say here, 0. So the question did say that we should use a matrix method to calculate the values of A, B, P, and Q. we have successful already in finding A to be equal to, say here, 1, and B here works out to be 0. All right, now we're going to just kind of erase, just make sure you guys have a screenshot of what is on screen here. All right, and then we're just going to just erase once again this information here, and we are going to go ahead then and redo the calculation, but this time we're going to be doing it for Q. So transformation Q, which we know now is P00Q, so that's P00Q, so that's going to be P00Q, and that again is going to multiply the object point, but this time we're going to be using minus 5, 3. So that's minus 5, 3. And then say here it's going to be equal to, after the transformation, it's going to be, say here, maps onto 5, negative 3. So going row by column, once again, same procedure. We're going to go ahead then and go row by column. So P multiplied by 5, that's going to be negative 5P. And then of course 0 multiplied by 3 is 0. All right, and then for the bottom part we have 0 times minus 5 is 0, and then Q times 3, that's going to be 3Q. And then of course we're going to equate that then to, say here, 5, negative 3. So then easily then we're going to equate the matrices. So we're going to form the first equation, negative P plus 0 is equal to, say here, 5. When we transpose positive 0, it's going to become minus 0. 5 minus 0 is 5. So we end up with minus 5P is equal to 5. So if we divide both sides by 5, you find that P is equal to 5 divided by minus 5. Easily then P is equal to, say here, minus 1. Let's just put a box around this. That's our value for P. Same procedure, then go back here and form the second equation at the bottom. That's going to be 0 plus 3Q, and that's going to be equal to, say here, minus 3. And then obviously then carrying the 0 over to the right side gives us minus 3 plus 0. Of course, that's the additive identity. Anything added to 0 will be the same number. So that's going to be 3Q is equal to, say here, minus 3. And so therefore Q is equal to minus 3 divided by 3. Aha, Q works out to be also minus 1. Let's put a little box around this. So we have this information here. So we can go down now to write our solution down here, that P is equal to minus 1. P, oops, let's have it in red here. So, okay. P is equal to minus 1. And Q is also equal to minus 1. All right, interesting question, dear guys. We had a lot of application in that. We had a little bit of algebra playing a role. We had a little bit of matrices, multiplication playing a role. So this is what CSEC is looking for when you get these types of questions. And bear in mind that it's not always going to be a traditional metric. I've seen examples, I've seen questions where it's just a random metric that they want you to use to transform the object onto a new image. But the process is the same. It doesn't matter the metric. All right, and then by extension here they have asked us now to state the type of transformation represented by T. So if we go back then, say here, to T, and we wrote down what is the metric for T. Okay, so let's go here and write down the metric for T. T equals, and we know that the metric T was A0 B minus 1, and we know that A is 1 and B is 0. So A is 1 and B is 0, and then we know that that was 0 and this was minus 1. Based on our knowledge, just looking at this, this seems that we have an X at the top and we have a negative Y at the bottom. Based on our knowledge, this apparently seems to be a reflection in the x-axis, because in a reflection in the x-axis, the x remains the same and the y change. So to answer this question, you most likely will have to have base knowledge about the changes in the points. So this is in fact a reflection in the x-axis. All right, and then finally then let's just write it here. Okay, the solution for this is going to be here. Okay, so it says state the type of transformation represented by T, and it was supposed to say by Q. You see this blue arrow here? I actually should have dragged down that blue arrow. So it's supposed to be represented by T and Q. So let's do the description for Q. We know that the matrix Q was equal to, say here, P00Q. So P works out to be -1. And of course, we know that that is, say here, 0. And then of course, this is 0 here. And then Q works out to be -1. So for this then, this is negative x, because we have an x at the top and that y, negative y at the bottom. So this is, there's two ways to describe this. This is actually, say here, reflection in, well, this in fact is a rotation actually. So it's a rotation of 180 degrees. So this is a rotation of 180 degrees. And you might ask, how did I know this? Because I know that in a rotation of 180 degrees, the x and y values are simply just going to change. The rotation video is coming up in a few days, guys, so you want to tune into that. Ensure that you have the subscription button on, the notification bell on, and you have already hit the like button before exiting this video. All right, so that really puts a wrap on, say here, reflection. Later on in the tutorials, we're going to be looking at some special combination transformations that you have to take note of. One, we're going to be looking later on at the glide reflection, where this is a transformation that maps or combines a reflection, whether it be a standard or non-standard reflection, followed by a translation, or it could actually be a translation followed by a reflection. We're then going to be looking at what is known as successive transformation, okay, in parallel mirror lines, and we're going to be looking at successive transformations in non-parallel lines. So that's going to be a separate video. This is more of an advanced video. So if you're not really interested in getting in depth, like in terms of exactly is a transformation, right? If you're not going in depth and you have knowledge, yes, depending on the level of math that you're doing, then this video may be or may not be for you. So I'm going to make this at the end of the rotation video and the enlargement video. All right, so glide reflection, successive transformations in parallel and non-parallel lines. These are things that CSEC will ask you at the end. Sometimes it values, say, 3 marks. So you definitely want to have an idea of what is meant by parallel and non-parallel successive transformation. So as you can see here on screen, what comes up next is rotation. And so we're going to be diving into what exactly is a rotation, angles of rotation, center of rotation, clockwise and anti-clockwise. That's going to be a very interesting video. So do look out for that in a few days. Until next time, guys, take care. My name is Akin, your math instructor. I do hope that you got some clarity on the topic and you're now in better understanding. Good luck on your exams coming up. Continue to practice, guys, and you're going to be geniuses. You're going to be geniuses in the very near future. Until then, take care. Bye-bye.